To size medium voltage motor backup current limiting fuses, the objective is to protect the motor from damaging overcurrents while allowing normal starting and operation. Firstly, determine the motor operating current. Obtain the motor's full load amperage, or FLA, from the motor nameplate or manufacturer's data. Secondly, select the fuse current rating. Choose a fuse rated for a current value that is several times the FLA but below the motor's allowable short circuit current. The National Electrical Code does not provide specific guidance for sizing these fuses. However, industry practice recommends using a fuse rated for 6 to 10 times the FLA for backup protection. Thirdly, choose the fuse melting time current characteristic. Select a fuse with a melting time current characteristic that provides adequate protection for the motor. The 15 to 35 second melting time at 100 times the R number is commonly used for backup protection. This means that the fuse will melt within 15 to 35 seconds when subjected to a current that is 100 times the R number. Fourthly, calculate the R number. The R number is determined by dividing the fuse current rating by the current value at which the fuse should melt at the desired time delay. For example, for a fuse rated for 300 amps and a melting time of 20 seconds at 100 times the R number would be 300 amps divided by 100 times 20 amps, which equals 0.15. For a 400 horsepower motor with an FLA of 52 amps, you could firstly select a fuse rated for 6 to 10 times the FLA, for example, 300 amps, which is approximately 6 times 52 amps, or 520 amps, which is approximately 10 times 52 amps. Secondly, choose a melting time current characteristic of 15 to 35 seconds at 100 times the R number. Thirdly, calculate the R number for the 300 amp fuse. R equals 300 amps divided by 100 times 20 amps, which equals 0.15. Therefore, the appropriate fuse for this motor would be a 300 amp fuse with an R number of 0.15 and a melting time of 15 to 35 seconds at 100 times the R number. It's important to consult with the motor manufacturer or an electrical engineer to determine the specific fuse requirements for a particular application.